This question is actually kind of tricky. We got to do a little bit of thinking, and then the algebra is a little bit uglier because we're solving for the speed of the object. But basically what it comes down to is we're hearing the frequency. We're asked to find the speed when the perceived frequency is double the actual frequency. For the notation that I've been using, that means that the perceived frequency is 2 times the regular frequency. I don't know what the regular frequency is, but the perceived frequency is double. The only time it's going to happen, the only time we'd get a higher frequency is when the car is driving towards you. The car is driving towards you, the distance between you and the car is getting smaller. That's why you hear a higher frequency. That means we're going to use the version of the equation with a negative. Doppler effect equation is this weird f multiplied by the ratio. Because it's a higher frequency, which means the car is approaching, I'm going to put a negative down here. I'm just going to call it letter V, and that's what eventually I'm solving for. The V that's on the denominator of this ugly equation. I don't know things exactly, but here's what I can sub in. Wherever I see f prime, I can write down 2f. That's what double the frequency means. I'm still got an f on this side. The speed of sound is 340, and then on the denominator, I've got 340, take away, I don't know. Algebra-wise, I'm going to multiply both sides by 340 minus v. That'll clear my unknown off the denominator, by v, not v naught. That'll clear my v off the denominator. I don't like having my unknown on a denominator, but really that cancels this out of here. And on the left, I've got 2f multiplied by 340, take away v, equals f multiplied by 340. I maybe could have done it sooner, but I'm definitely going to do it now. I've got an f on the left and an f on the right, so those cancel out. Algebra-wise, I'm going to distribute the 2 into my brackets. 2 times 340, I can do that in my head, that's 680. Take away 2 times v is 2v, and that's equal to the 340 I had on the other side. Now I've got to do a little flipping, bring the 2v over here, bring the 340 over there. 680, I have to take away 340, that's going to get me back down to 340, and that's equal to 2v. The last step is to get v all by itself, divide both sides by 2. I get v equals 1/2 of 340, which is 170. If you're up for a challenge, go through that proof or go through that solution again, but don't put in a number for the speed of sound. Just call it x or something. The x's end up canceling out, and you're going to get this cool solution that to double the frequency, you need to drive half the speed of sound.